in my lesson today, I am going to discuss the working principle of a potentiometer. Alright? So, right in my hand is a material, a device, an arrangement, a physical representation of a potentiometer. Notwithstanding, this material can be used for 2 or 3 purposes, such as the practical application of a Wheatstone bridge, which is a meter bridge. We can convert a Wheatstone bridge into a meter bridge using this. Alright? Also, we can use this as a potentiometer to compare the EMFs of cells. So you can look at it very well. Now let's show some kind of comparison, right? You have things I won't show here. The rheostat is not here. The standard resistor is not here. But I'm just showing this from X to Y represent this length of a meter rule. Can you see that? Alright? That's what it means. Then there is this dash, 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 down to X end. That's the tiny cross-sectional wire. You can see. Okay? That's the cross-sectional wire here, resistance wire. So to say, then another thing, we have some connecting wires. Right? This is connecting wire. Okay? This connecting wire for these arrangements, we have brass bars, where some other connections will take place, such as the cell 1, cell 2, or cell 1, cell 2, the keys, and where the galvanometer will be connected. So look at it. Very simple and very clear according to what we are discussing today. Alright? That has to do with the center of my discussion or lesson today. So look at it. It has terminals, different terminals for representing our diagram on the board. So you can turn it and see everything around. Alright, having shown this, let's begin to explain all we've got here. The diagram is very simple, right? And I want us to see that way. I'm still holding it in my hand. So, in this general representation of a potentiometer, this is a rheostat. A rheostat is used to vary the resistances in the circuit. So when you vary it, you get a particular value that will be used for what you want to achieve. So that's what it means. Then X and Y, as I said earlier, represent the cross-sectional meter, the uniform meter rule, so to say, not cross-sectional, the uniform meter rule. That's this. Okay, we have a standard resistor. The standard resistor will be provided in a situation we want to do the practical aspect of this, but I'm just doing some kind of explanation. That's this. Then the galvanometer, the same thing. The galvanometer is a sensitive instrument or device that must detect and measure small amount of current. Alright, so I've mentioned the rheostat, the standard resistance, resistor, a uniform meter rule have been shown, a sensitive galvanometer has just been explained, and finally, a uniform resistance wire is just the one I tapped at it and then showed you what this is all about, okay? So these are things we see where we are going to make some connections by the time we put this into physical, practical use. Okay, now, having said that, let's see. Now, what about this? Why are we so much interested in knowing things about a potentiometer? Very, very important. A potentiometer does something that a voltmeter ordinarily cannot do. One is a device that measures the potential differences across points. Of course, you should know the points X and points Y must have in each unit along the length of the wire must have different potential drops. To measure these different potential drops, you need a potentiometer. And that is what it does. Okay? Then the next thing it does is it measures, it compares the EMFs of cells connected in a circuit. So it does some amount of comparison. A voltmeter does not do that. Now, Yeah, it doesn't do that. So it's an advantage over a voltmeter. The third one is that it can be used to measure resistances in a given circuit. Another advantage over a voltmeter, right? Even though I'm still going to teach in detail advantages a potentiometer has over a voltmeter. But I'm doing so because it has to do with its functions as well. Then the next one is it uses a steady current value to measure potential drops. So the current must be steady. The current must be steady for it to be able to measure any amount of potential drops along the length of the meter rule. Remember I said that each unit has some amount of potential drop that will be witnessed or that will be recorded or measured by the potentiometer. And finally, the last not the least, it precisely gives the actual values of EMFs of the cells. It just gives exactly. If the cell is 2 volts, it gives you 2 volts. Doesn't change it. Not 1 point something or 2 point something. No, exactly the value will be recorded or measured when you are using a potentiometer. Isn't that interesting? Very, very interesting. Now, we have said all that. All right? We have said all that. Very good, and we have learned something from that. Now, if you have really found value in what I am doing, and you're still watching without subscribing, come on. You can do better than that. I don't want to go further saying this. Let's go into how it works. Look at that section. We have taken time to outline 1 or 2 things about how a potentiometer works. It works in a very simple way. The first thing is that under a steady current, there is a steady potential drop along the wire, which is in connection with what I said earlier. The second one is that each unit, I said it before, each unit, all right, of which unit length of the wire, okay, will have a potential drop across it. That is how it compares everything. That is how it compares potential differences or measure potential differences along the length of the wire. And finally, we have, by the time we determine each length, the voltage drop, that's VL, against the length. That's what we're doing here. That's what the potentiometer does. That is what it does. This is absolutely interesting when it comes to comparing the EMFs of cells. My dear friends, my dear viewers, learning is very interesting when you understand how to teach and how to pull together the attention of your students. And that's what I'm doing, making it look live. Okay, putting life in teaching is very important. Okay, so having said that, can you see, we can practicalize this and get some amount of results. But without wasting time, for us to solve and find the value of C1, which represents potential drop across these points, or the value of C1 as the EMF we're looking for, we can apply any of this, where we have V1 over V2 equal to L1 over what? L2. This means if you get the potential drop at point 1, there must be some amount of length at which you get such potential drop. If you get to that point, potential drop for point 2, there is also a corresponding length, L2. The same thing applies here. EMF 1, a corresponding length, L1. EMF 2, a corresponding length, L2. That's all. That is all. Okay? This should serve as an introduction to potentiometer. A lot of things to say about a potentiometer. But that will be done in my next class, where I'll be linking it up there or somewhere there. But don't forget, we have just done potentiometer. See you in my next class. I am signing out. Are you still there? Subscribe. Come on. Thumbs up. Come on. Bye.